All right, so I'd like to go over the review question in the exercise guide. And so it says, why are you creating a sandbox? We didn't actually cover this yet, but I'll explain it. So Herman, I'm going to let you off the hook. So the reason we're creating a sandbox is that in the Force.com platform, one of the things that you need to do is you need to do your Apex development in a sandbox environment. In other words, in a developer environment separate from your production environment. So you do not want to be writing code. In fact, we have safeguards so that you can't write code in your production environment. You don't want to be doing things that are affecting your current user's environment. So one of the things that Salesforce has, the Force.com platform has, are sandboxes. Sandboxes are separate environments that can be used for multiple purposes. We'll talk about those later. But the purpose we're going to use it for is a development environment where we can segment our work and then be able to make changes, make mistakes without affecting our production environment. Okay? Later on, a couple days from now, one of the things that we'll do is we'll take some code and we'll promote it or deploy it from our sandbox environment up to our production environment. Okay? All right, so we will come back to that production environment. All right, let's get going on Apex. All right, Apex allows us to create code which is of much greater complexity than the things like the workflow rules, the validation rules. So it allows us to create intelligent and complex code at a much further level beyond what we're able to do within the point-and-click environment, within our declarative means. In addition, we also support transactions. So we'll talk about how we can enable transactions and things like committing data or rolling it back, depending upon the different conditions that we run across. In general, Apex is a procedural language. It kind of depends on how what you're looking at when you're talking about Apex in terms of, is it object-oriented or procedural? Our triggers that we create are very procedural in the sense that the trigger fires and executes code much in the same way if it were if it were a single method. Now that being said, we can create Apex classes, we can define variables and create methods and then instantiate objects based on those classes. So it's very object-oriented in that way. It runs on the Salesforce servers. So the code that you create is actually compiled on the Salesforce servers and runs on the Salesforce servers. It's an interpreted language. So it's one of the things that happens is that we have an interpreter. When it's requested, the code will be compiled at that time and executed upon the request. It looks a lot like Java, and it's probably, if I were to make a rough estimation, it's probably 75% similar. It's the 25% that gets people in trouble. So if you look at it, it looks very similar, but there's a lot that goes into it that's different, and we'll talk about those differences as we go on. Apex in general does a lot of things, but triggers specifically attach business logic to the save process, similar to something like a validation rule, which executes upon record save, same thing like a workflow rule. But our Apex triggers allow us to attach logic to the save process, so upon an event occurring, we can then execute some Apex code. It also has built-in support for unit testing, so we will cover that. In fact, it not only has built-in support for it, it has requirements for unit testing. And we'll cross that bridge later. This slide here is really referring to triggers. So Apex triggers execute. It's one of the primary means by which we can execute Apex code, or Apex triggers. Apex triggers execute when data manipulation or DML events occur on the Salesforce server. What's a DML event? Well, DML, or data manipulation language, is any time that we are writing to the database. So whether we're doing an insert or an update or a delete, or actually a fourth event that we can detect is an undelete. So any of those things in which we are changing the database will fire off some Apex code that we can write and then execute some custom logic. So, Apex triggers are not tied to a button or a specific portion of the UI. Now that being said, Visualforce controllers are written in Apex and they are specifically tied to buttons and our user interfaces. So, yep. There's a lot of similarities with Java. So the looping, the class declaration, the concepts or the syntax associated with calling methods, passing arguments to those. There's a lot that's very similar to Java syntax, or for that matter, C# syntax. We also pass by reference, similar to Java. And then it's a strongly typed language. So one of the things that you'll see is that we'll be, unlike JavaScript, there's no implicit typing that goes on. So we explicitly declare our types. There's a couple of big differences, especially when you're comparing it with Java. One is that Apex is case insensitive. So Java is case sensitive, so an uppercase variable called hello is different than a lowercase variable called hello. That is not true in Apex. So keep that in mind, that your Apex code is case insensitive. All right? So when you're declaring those variables, they're the same thing regardless of the case. It runs also in a multi-tenant environment. So another big difference is the fact that your code is running in a shared environment. Therefore, you can't hog things like database connections. You can't have endless loops. Will eventually stop an endless loop from running within the environment. So, all right, here's some sample code. This is just kind of a teaser in terms of taking a look at the different things that exist within Apex. So similar to Java, there's a declaration of a variable, and then here we have an assignment. This is similar to, if you were declaring a new int in Java and assigning it a value. In our case, though, even though we call them primitives, Apex is really truly object-oriented in the sense that actually the primitives all extend an object class. But we can do the sort of initialization and assignment the way we've done on that first line. We also can declare a list of something, in this case, account with the open bracket or open square bracket and the closed square bracket. So actually it's not an array. It is a list of accounts, and so we can declare a list of accounts, and then here we can assign the return of what we call a SOQL query to that variable that we just declared. Okay. The delete ACCS is an example of a DML operation. This is where we're actually going out and modifying the database. So we've seen both the query of the database using our SOQL query, and then the update or the changing of the data in the database by doing that delete command. We'll talk about how there's multiple methods or multiple ways that you can do DML operations, but the most simple way to do it is just by using these single word commands like delete ACCS. Here's a looping. Here's a for loop, so we can do things like standard for loops, so standard looping constructs like while loops and for loops. Here we're creating this list, another list. And here is what I would refer to as a for each statement, where we're iterating through every element within the list. We have a special syntax for doing. I'm not sure if this is, you call this a special form of the constructor or what, but one of the things that we can do when we're declaring S-objects is be able to assign or initialize field values by using this name value pair notation, where we say field 1 equals some value, comma, field 2 equals some other value. In addition, we can also use dot notation. We could say, if we had a single contact, we could say something dot, much in the same way if we had a object with a variable in that object, with an S object or one of our Salesforce objects, one of our custom objects or standard objects, we could do the assignment of a field to a value. Okay, we'll come back into this. The purpose of this is just kind of to be kind of a teaser to show you, just to get your feet wet, but we'll come back into talking about a lot of this stuff. So, all right. Apex provides built-in support for our database operations, whether you're querying the database or updating the database. So you don't need to import some sort of library, something like a JDBC library in order to operate against the database. It's built in, it's native to the platform. So both updating and querying the database. There are looping control structures, for loops, while loops. We'll take a look at those. There's a record locking syntax. We can create custom web services in Apex very easily. We can send and receive emails. We can also make callouts to external systems. We'll show you that. There's error handling and the ability to do debugging. And then we have a unit testing framework that we'll be taking a look at. Unlike a lot of other programming languages, Apex is not a general purpose language. So what do I mean by that? Well, there's in Apex, you're never going to see that main method. Apex is executed by the Salesforce system. So your Apex code is ultimately going to be called by different events that occur within Salesforce, like, for instance, the database write in the case of a trigger, or if you create a visual force page, the visual force page making the request up to the visual force controller. But there's not a concept of something like a main method where you can just create a general program that does something and then fire off that program. Apex doesn't really render elements in the user interface. If we wanted to do that, we would use Visual Force. So Visual Force Pages is the mechanism whereby we create custom user interfaces. We can't change the underlying functionality of the off-the-shelf Salesforce applications. Now that being said, this change standard functionality is a little bit vague, but we can, for instance, change the functionality of our applications by creating Apex code. There's no access to the file system, so you do not have file I/O access, nor can you create threads. So there's no concept of spawning a new thread like you might do in Java, nor do you have socket level access. You can't open up a port. Now that being said, you can create an HTTP request and, for instance, do web service integrations by doing a request out to some external system. Nor do you have access to whether it is your Java libraries, so you can't upload some sort of Java library, nor the underlying Salesforce Java libraries. So Salesforce is a very large Java application underneath the covers, and we do not have access to that underlying code within the Apex environment. Apex itself is abstracted a layer above that and runs, as I said, through the interpreter in terms of its execution engine. So here we have the traditional code. It's it looks like atoms flying around, or at least reminds me of my physics classes. But here we have the code in which we could call into this or be able to do things with greater flexibility. In Apex, it's governed and execution is controlled by some sort of entry point into your code that goes through our system. So for instance, these different blocks over here, this lowest block might reference or this might be a visual force controller, this first block. That block or that block of code might perform a DML operation, in other words, update the database. That would in turn maybe fire off a Apex trigger, which might be our second block. That Apex trigger might update two other objects, in which case Here you see two other triggers fire. But all of this is a single transaction where the entry points to the code were defined by the action or the way that we interacted with the system. At the end of the day, though, the Salesforce system is the one that's running all of these requests in our governed environment. Okay. Not only is it a multi-tenant database, so we have a hugely scalable metadata-based database at Salesforce. There's actually presentations on this, which our developers discuss the multi-tenant environment if you want to learn more about this. We also have a multi-tenant stateless application server environment. So there are many pools of servers in the application, the code execution environment, which are handling essentially stateless requests that come into the Salesforce servers and then executing your code that you've created that runs within that environment. Okay. There's two primary components or things that you will be constructing within Salesforce when you're writing Apex code. They're Apex classes. The Apex classes are the mechanism. If you're going to create a custom web service or an email service, you would create a class, and then that class would contain methods and implement interfaces in order to fulfill its purpose. Now, different from other programming languages, there's this concept of a trigger. Now, a trigger is not a class. It's its own entity. And triggers are associated with our different custom objects, and like I said, they execute code as a procedure or like a procedure upon some event occurring. Okay? Now, in addition, there's also one other thing that's missing here, which is an interface. So you can create an interface, and then later on, you can create classes which implement that interface and the different methods defined within that. So let's take a look at an example of some code executing within our environment. So if we take a classic Salesforce situation, a user is entering in a lead into the system, and we're going to save that lead to the database. Now, one of the things that we are often attempting to prevent are duplicate leads. We could have created a Apex trigger which would fire upon that lead being written to the database. We would then take a look at that lead to determine if there's any sort of, we might define our own custom criteria for what is a similar or a duplicate lead. And then we would perform a query in the database to check to see, are there any similar or equivalent leads already in there? If there is, we can prevent the write to the database and display an error message to the end user. If not, then we can just simply allow the write to the database, and we would then allow the save to occur. For more information on how, in terms of following up, there's the Apex Developers Guide. This is, in terms of Apex development, the best place to go to. It's really, most of the information that you'll need is in this developer guide. You can download the PDF from developer.force.com. In addition, you can also access, there's HTML-based help out there also at developer.force.com. There's the cookbook. The cookbook is a lot of sample code, sample implementations of different things. Either our users or partners or developers have created to kind of show off some of the different things that you can do with Apex. Very helpful. In addition, there's also the Visualforce Developers Guide. This is a great place to go for information about Visualforce controllers, which we'll be talking about later. And then there's the Web Services API Guide. That has information about our standard web services. In addition, it also has some additional documentation on SOQL, our query language. Okay. All right. Apex is object-oriented. Apex is an object-oriented language. We can define classes and instantiate objects of those class definitions. We can also do things like churn on or perform things like inheritance, polymorphism. There's access control, so we can do encapsulation. So all the stuff that would go into an object-oriented programming language is available within within our environment. Well, one thing I'd like to point out is that we don't support multiple inheritance. This one's a little bit of a typo. So inheritance, unlike C++, we follow the model of Java, where we only support single inheritance. In other words, a class can only extend one other class. It cannot extend multiple classes. That being said, you can implement multiple interfaces. Okay, so you might want to cross out that multiple word down there. All right. Our code is written in classes and triggers. The class, if we're going to create a class, we can have variables and methods. In addition, we can also define things like constructors and static blocks in order to execute code. Ultimately, our code will be instantiated into objects. That'll call the constructor associated with our class definition. And then we can utilize dot notation to access the members of that object. Okay. Apex is on demand. So when you're writing code within the force.com IDE, which is one of the things that we'll be doing, when you write that code, we have some syntax checking functionality. But when the code is actually, I don't want to say compiled necessarily, because it is an interpreted language in terms of the way it runs up on the servers. But when you save that code will be uploaded to the Salesforce servers, and we will attempt to store that code in your metadata database, in other words, associate it with your organization. Now, one of the rules that exists is that if it doesn't pass the syntax checker, it will not allow that code to be saved to the database. So the only code that actually ends up in the database is code that's syntactically correct. Okay? But the key thing to keep in mind, or one of the key things to keep in mind, is that even though you're using Eclipse, there is no local compiler per se. All of that responsibility is handled up in the cloud by the Salesforce servers. So the code will be uploaded to Salesforce. We will ultimately, if it passes all the checks, store it in the metadata database. Then, when a request comes in, we will utilize the interpreter to execute the code and then execute the logic that you've created. Okay. Governors and limits. All right, so one of the big differences between Apex and other languages is the fact that Apex has governor limits. So there's a few, I think if you were to try and identify what are some of the key things that we are looking to control. One, it's inefficient database I/O. The second is sort of out-of-control programs, or programs, something like an endless loop, something like a while loop that doesn't have an exit condition. So we'll be monitoring the execution of your Apex code and applying these limits so that your application, or for that matter, someone else's application, is not monopolizing the resources. Okay? This is going to come back into play, and one of our focuses this week is to focus on writing code, and we'll try and point out where we can do things to write code that is going to work well within the context of the governor limits. Okay. The governors are monitoring the execution of your code and applying these limits to the execution of the code. Governor limits are transaction-based. There's a little bit of a difference between the web service limits associated with Salesforce and then the governor limits. Web service limits are based on daily totals. So within a 24-hour time period, you can make, if for our larger sites, you can make up to, for instance, 5 million calls at scales, depending upon the version type and the size of the license. But our larger customers can make up to 5 million separate web service calls per day. That is a time-based limit that we apply to the web service calls. Now, for the execution of Apex code, the governor limits are transaction-based. So the limits are being applied to a specific transaction that's being executed when we make that, for instance, going back to that example I specified, where a user called a controller, the controller updated the database, and it fired off 3 triggers. All of that would be a single transaction that executed within our environment, and we would apply the governor limits to the entire transaction. So I'm just going to jump back a little bit to show you that slide. So if we take a look at the right side of this slide, all of the things in terms of the controller, if the controller was the first thing that executed, that's some Apex code, some custom Apex code. That then fired off 3 separate triggers. All of this is considered a single transaction from the standpoint of enforcing governor limits. Okay? In addition, we also apply different levels of governor limits depending upon the entry point to the code. So for instance here, the entry point was, our first entry point in terms of custom Apex code was our controller. There's one set of limits that we apply associated with controllers. If the entry point to our code, our custom Apex code, was a trigger, then we have a second set of limits that we'd apply. There's a third condition, which is when we're running our unit tests, but in total there are a total of 3 different sets of governor limits that we apply. Like I said, they are determined by the entry point to the transaction. Okay? If your Apex code, if the transaction exceeds the specified limit, a runtime error will be thrown. It's not something that you can catch. So it's not something that you can recover from, but what will happen is an error message will be displayed. There's also some Apex warning email functionality that we have associated with the user object, so you'll receive an email if you've enabled that for your specific account. There's no way to enlarge these, so this is not something that you can, customers ask if they can kind of buy their way out of these, but they, like I said, they're transaction based, and it's not something that's necessarily we can toggle on or off. They always apply, and it is not associated with, for instance, your license type or a different level of license that you might have. As I said, limits are different depending upon the context of the code execution. So we have 3 different limits that we apply, and I'll show you those in a second. Limits can be sent via email. They also appear in our log files. One of the things I'll show you later on is we have the system log and the debug log. We'll take a look at that, and we can see our governor limits, and it'll tell us where things are executing. There's associated with the user account is a checkbox called Send Apex Warning Emails. Enable this to receive the Apex governor limits, warnings, and exceeding those limits. In addition, governor limits, if you're using App Exchange code, so let's say that you're using some code that you downloaded from the App Exchange, that runs in a separate namespace, and anything that code is doing does not apply to your governor limit context. So it only applies to the code that you write. Okay? All right, so let's take a look. This is a screenshot that's taken directly from the documentation. And so one of the things I would recommend is when you get the chance, go out to the Apex Developers Guide and take a look at the full list. This is a subset. Some of the most important ones are at the top, but this is a subset of all of the governor limits that apply. Let me point out some of the more important ones. Over here, the first few things are associated with database and also our search engine I/O. So for instance, the total number of SOQL queries issued and the total number of records returned by SOQL queries. This is associated with querying the database, therefore associated with our database I/O. We also have further down the list the total number of DML statements issued. So same thing goes for it, except here we're operating on the database in terms of writing to it. Then there's also some limits associated with SOSL queries. SOSL is our search language where we can do free text search within Salesforce applications. So these first 6, if you think about it, they're all kind of associated with database I/O. And in application, if you're creating something like an enterprise application, web application, typically the number one performance issue that people run into are associated with database I/O. So it's the number one bottleneck that exists within those web-based enterprise applications. Well, these limits here are really attempting to circumvent or to prevent excessive database I/O in terms of accessing the database from your code. There's also some other things I'd like to point out. There's some footers associated with this, and so when you see the total number of records retrieved by a SOQL query, it says 1,000. That is not 1,000 to the 6th. That is a reference to a footnote number 6. Okay. What that footnote says is that this particular governor limit scales with the batch size, the input batch size of the transaction. So for instance, one of the things that we can do is using our web services API, we could insert up to 200 records at once as a part of a bulk insert using our web services API. Well, what this is saying is that when you're performing SOQL queries, we would then take that 1,000 number and then multiply it by the size of the input set. So very frequently, these limits will scale according to the batch size that is a part of this transaction. If we take a look, let's take a look at a few of these specifically. So the total number of SOQL queries issued, 20. So within the context, if the entry point to your application is a trigger, then 20 is the number of separate calls, round trips out to the database that you can do within the context of your code. In terms of the size of the data that we get back, so the total number of records returned as a part of these SOQL queries, like I said, it's 1,000 for a single record, but this scales according to the batch input size. So if I had 5 records coming in, then this would scale up to 5,000 as the total number of records I can get back. You'll notice that the second column, which is a little bit hard to read, but it says anonymous block, visual force controller, or WSDL method, in other words, a custom web service that we've created. If we're executing, if the entry point to our Apex code is one of these mechanisms, then we apply the limits for the second column. So for the second column, you'll notice that the total number of SOQL queries issued actually scales up to 100. Okay. The number of SOQL or the records retrieved is also 1,000, and then same thing goes for same sort of proportion when we're talking about the number of DML statements executed. In the case of the total number of records processed as part of the DML statement, it's 100 for a trigger, but then 10,000 for one of our visual force controllers or one of our custom web services. Once again, that 100 number scales according to the size of the batch size that fired this off. There's the total number of executed script statements. This one also scales in the context of a trigger. It's 10,000. This is kind of the thing that's looking out for. We place a limit for that while loop that doesn't have an exit condition. So eventually, after a certain point, we're going to prevent that from continuing to run. There's the 3 is what this is referring to is that these also scale according to the batch size, but in this case, it doesn't scale in a linear fashion, so you don't simply take the number and multiply it. The way that these scale when it's the number 3 is that if it's 1 through 40 records, you multiply it by 1. If it's 41 through 80, you multiply it by 2. And then so on and so forth up to 200, where ultimately it could be 5 times as large, that particular number. And then there's things associated with size of a string. So your string size, let's see here. There's one of the things we'll talk about are different collections. So a collection, there are 3 types of collections. There are lists, sets, and maps. Each of those can contain 1,000 elements. That being said, you can create multi-dimensional collections. So you can create a list of lists. So you can, if you're a little bit creative in terms of the way you write your code, you can get past that. These also scale according to the, the 3 basically is the multiplier effect up to 5. Okay. All right. So the point of these governor limits are to ensure that somebody else isn't writing code. I know none of you will do this, but somebody else is writing code that is consuming or monopolizing the resources that will allow your code to execute very quickly. So one of the things that we want is code that runs within the Salesforce environment to be able to execute very quickly and to meet the high standards of our customers. When you reach the governor limits, there are usually some pretty straightforward things to look for. So for exceeding the total number of SOCL queries, are we possibly creating or executing SOCL queries within the context of a loop? So a classic problem is placing the SOCL query inside the loop. Once again, like I said, something that's kind of acceptable. If you're a little bit lazy in terms of writing your code, you can get away with it when you're doing your unit testing. But once your application, you start putting load on that creates a significant amount of data I/O. So move those SOCL queries outside of the loops. We also have the ability to do batch queries, so we'll talk about how you can do that. So we can, if you want to select multiple things at one time, we can do that. We're exceeding the total number of executed script statements. Take a look at recursion or looping once again. Exceeding the number of DML statements, in other words, the number of times we're going out to write to or save to the database. Typically, you're not doing things, once again, we might be in a loop, but take a look at doing things when you're doing the DML operation. We have the ability to do bulk inserts and bulk updates. So it requires you to write code that is going to collect everything that you need to update, and then at the end of the code execution, or before the end, then perform that bulk update against the database. And then we're exceeding the total number of records retrieved by our SOCL queries. Take a look at the where clause associated with your SOCL queries. So are we, selecting too many things, and then can we select less by adding criteria? Apex is a proprietary language. It is strongly typed to our Salesforce metadata. So one of the great things about Apex is that the Salesforce servers, one of the things that our environment does is it takes a look for references to other things, like, for instance, fields. So let's say that in your code, you write a line of code and you're going to operate on a field in a Salesforce object, a custom or standard object. If you go in and attempt to delete that custom object, what's going to happen is that when you're in the declarative menu and you delete that, it's going to prevent you from doing that. And it's going to say, here are all the different triggers and classes which are referencing that particular field. Therefore, in other words, it's tracking the fact that there are links that are now established, and by deleting this field, you would ultimately break your code. And like I said, it will prevent you from doing that. In addition, it will also tell you where this specific thing is being referenced. Okay? When we're writing code, as I've kind of already alluded to, we can programmatically operate on and reference our different objects and our different fields. So we natively are able to declare, I refer to them as S objects. We'll get into these more later. S object, S is short for a Salesforce object. We can instantiate what essentially represents a record within the Salesforce system. It can be a standard or a custom object, but we use the same syntax and notation for creating that or defining that reference. So, In addition, one of the things that we do is we associate a version number with your Apex code. So even though we recently moved from Spring '09 to Summer '09, every Apex class, for instance, had a version number associated with it. So our previous version was 15.0. We're now running at 16.0. Because we associate a version with your code, we ensure that if we made a change to the syntax, your code can continue to run using the interpreter associated with that previous version of Salesforce. So when we went from Spring '09 to Summer '09, we do this so that we enable backwards compatibility and prevent the breaking of code by enabling new features. Okay. All right. In order to write Apex, there is a profile permission called author Apex. In addition, there's limitations in terms of where you can write that code. Code is primarily written in one of two places. Either in a developer edition org, you can write Apex code there. The other situation is in sandboxes associated with Unlimited and Enterprise edition orgs. One of the things that we do, and we'll talk about once again, we'll cover the details of this later, is we have requirements for test code coverage for the number of lines of code coverage associated with your business logic or your Apex code that you create. That prevents you from directly writing code into your production environment. You need to create the test code that then calls the business logic that you've created in order to get it into that production environment. So at the end of the day, two main places that you can write code: developer edition orgs, and then sandboxes associated with your Unlimited and your Enterprise. The Apex, the ability to write custom Apex, is not supported in the personal group or professional edition, and that's why they're not listed here. Now, in terms of executing the code, so what we were talking about is writing the code. In terms of executing the code, well, you can execute it in a DE, an Unlimited, or an Enterprise Edition org. You can also execute code in one of our other orgs, as long as that code was written by one of our AppExchange partners. So you cannot write your own code if you're in a professional or a group edition org. But like I said, you can install an AppExchange app that's a native app that contains Apex and execute that. To create things like triggers and classes, or the place where you can find them, is associated with, triggers are associated with the DML events associated with each object. So we find them in the, when we're editing a custom object, we'll find our triggers listed at the bottom of that, and there's where we will go to see them. Actually, in Summer '09, we also have another area under the setup menu, Develop Apex Triggers, where we also list all of the triggers. So it's a place that you can now go to. Your Apex classes are going to be under Setup, Develop, and then Apex classes, and there you'll see a list. I recommend that you are, from the very beginning, you come up with a naming convention. So if you do have a large number of classes, to help you sort through the different things, like coming up with something like identifying your controllers with some sort of naming convention, or associating something, if it's a business purpose or a specific application that this code is associated with, something to help you to navigate through all your classes. In our case, we're going to be using the force.com ID. So everything I've talked about is how you would access these from the setup menu. What we're going to be doing is using the force.com ID to create and take a look at these. All right. The force.com ID is our development environment. It's a plugin for Eclipse. It allows us to write our code. It has things like syntax highlighting. It shows us our syntax errors. It has code completion in certain ways. It allows us to execute test code, execute what we call anonymous blocks. It allows us to browse our data model using the schema browser. So there's a whole bunch of functionality built into that. One of our first exercises is to install the force.com ID in the Eclipse environment. When you create a project within the Force.com IDE, what you're doing is you are entering in connection settings for connecting up to your sandbox org in order for you to be able to write and read from the metadata database for your metadata definitions that exist associated with your org. This isn't just Apex code. So in addition to Apex code, it's also going to be your visual force pages. It can also be custom objects and page layouts. So all of these have metadata definitions that we serialize or we place into XML file formats that you can then edit through the Force.com IDE. Okay, so that's one of the key things to understand about the Force.com IDE is that you're operating on local versions, but then what we'll end up doing, because we're connected to our org, when we click on that Save button, the changes will be updated to our server. Okay. All right, so now that we have the Force.com IDE installed and we've created our Force.com IDE project or our Force.com project, what I'd like to do is just take a few moments to kind of show you some of the key features of utilizing the Force.com IDE. Well, first of all, what you're going to see under your project after you've created it is a list or a set of folders of all the different types of items that exist associated with your org. So for instance, applications, this is referring to the different applications, the custom applications that you've created. In my case, I have two custom applications, the custom administration application and the recruiting one. Remember that this is a Salesforce application. It's largely just a collection of tabs. But then under here, there's a much greater amount of stuff that I have where I have a large number of Apex classes. So all these classes are represented in a file format. If I double click on one of them, what it will do is it'll open up the editor associated with that class, and then I can go in and begin to make changes to my code. So in this case here I have a class called the address validator. And then there's, right off the bat, there's some variables that are available and then some methods. There's a method right below it. So here's where I can then start working on my code. Like I said, when you make a change to your code here, so if I added an additional comment, so commenting in Apex is very similar to commenting in other sort of C family of languages where we do the double slash or the slash asterisk. So here is another comment. What's going to happen is that that's going to then, once I save this, you'll notice in the lower right-hand corner, one of the things it'll do is when I save this, if you take a look, it says building workspace in the lower right-hand corner. What it did was it took my class definition, uploaded it to the server, so that it could then go through the syntax checker and ultimately store it within my metadata database. Okay. So this is an IDE, so I can write my code. There's, like I said, there's code highlighting, as you can see. There's code completion in certain situations. What I'd also like to point out, so let's keep going on down here. There's something called the schema browser. The schema browser is after the source folder. The schema browser is this blue icon, and what it allows us to do is it allows us to view our data model. We can also execute SOQL queries against our database in order to perform sample queries. So let's take a look at the schema browser. One thing I'd like to recommend, especially if you're like me and you're often on a low resolution, is if you double click on the tab. In Eclipse, what that does is it maximizes the window as greatly as it can, and that gives you a lot more room to operate. Over on the right-hand side, so after we've double-clicked on our schema browser, over on the right-hand side is a list of all of our data objects. So it's our data model that exists within our org up in the cloud. So right off the bat, the first thing that is in the list is the account. And if we take a look at the account by expanding the account object, you'll see that there's some information associated with or telling us about the metadata associated with our account. One of the key things here are the different fields that are available on our account object. So here we see a large number of standard fields, things like the billing address, the shipping address, also things, standard fields like the created date, industry, all the different things that make a specific account unique compared to other accounts. In addition, if we add custom fields, we'd also see our custom fields here. Now, one of another feature of the schema browser is that notice on the left-hand side, there's a query up here. It looks like a SQL query. That's a SOQL query. And so I can come out here and if I select, for instance, the name, and then let's say that I select, let me see if there's any of these have, see if any of these have any information that's worthwhile. But here I'm going to do name, industry, and billing city. Well, these are 3 standard fields on the account object. By clicking on these fields, what it does is it dynamically generates a query for me, and then I can click on this run query, and what it will do is execute that query against the database. As you can tell, I have 5 accounts within my database. I can also come in, and this is an editable window, so I can create a where clause, and I might say something like where, you know, a dot name equals, and then why don't we say I think we have Salesforce.com. Okay, so I can jump out there, update my query, and then here I added a where clause and said only where the name is equal to Salesforce.com. So you can not only easily generate queries using the schema browser, but you can also edit those queries in order to run sample queries to see what happens. This is running against your database, so this is, if in my case I'm in my sandbox org, but if you're running this, it's actually going out to the database and querying your data tables. There's also other interesting information in here, things like the child relationships. So one of the things that our accounts have are child relationships, and we can access associated contacts, for instance. So contacts have a lookup to an account. So I could expand this, and for instance here I can get my relationship name. So in a, programmatically, we'll come back to this, but from an account, I could access the related list of contacts associated with that contact by utilizing that name, whatever the name of my contact object is, dot contact. So that relationship name is telling me how I can access that related list depending upon my object type. In addition, I can also, if I wanted to, I could come out here and maybe do first and last name, something like that. And now I can run my query again, and then notice it selected, it had that nested query there where we're selecting the last name and the first name from each all of our associated contacts or related contacts. Now I can click on the contacts here. A little bit hard to tell because we got the blinking cursor, but if I double click there, it then tells me, okay, in this case for the account Acme, I have 4 contacts associated with this particular account. So double clicking on there will bring that subquery up. Okay. All right, so like I said, the schema browser is very helpful, especially when you're trying to figure out the what we call them sometimes the API name or the underlying name of the things that we're trying to access. So often when we're taking a look at the tool, we're seeing the labels. The labels contain spaces. It's information intended for the end user. But as programmers, we need to find what's the underlying API name that I need to know to access. So if I'm taking a look at a candidate here, for instance, notice that there's a large number of custom fields. If I want to refer to, for instance, here we have the legacy candidate number, it's going to be legacy underscore candidate underscore number double underscore C. Okay, so it's important to know that underlying name. So. All right, I'm going to exit out of the schema browser. There's a number of other things that are available. So Problems, so anytime we have syntax errors, we'll see our syntax errors, either warnings or errors as they appear in the Problems tab down here. There's the Apex test code runner. We'll come back to this later when we start to do our unit tests. This is the facility within the Force.com ID whereby we can execute our Apex code and run our unit test to see that we're not throwing any exceptions, or I should say uncaught exceptions. There's also a feature called Execute Anonymous, and this is an important feature because anonymous blocks allow us, Execute Anonymous and anonymous blocks, I use the terms interchangeably, but they're referring to the same thing, which is to run an anonymous block allows me to run a snippet or a section of code and then to execute that against the database and to view the results. So if I come out here, one of the more simpler lines of code, if you're a Java programmer, this would be roughly equivalent to doing a system out print line. But one of the things I can do is do system.debug and then hello class. Okay, and then I can execute that line of code by clicking on the Execute Anonymous button. And here what we're seeing is that in this third line here where it says hello class, that's actually the line of code that was outputted as a part of this debug. So this Execute Anonymous, it executes the code. Key thing to keep in mind is that if you update the database, you are updating the database. So unlike our unit tests, which we'll talk about how they don't commit data to the database, our anonymous blocks do. Okay? All right. Okay. We also have, I'm not going to get into it in great detail here, we have a lot of information out on developer.force.com associated with integrating with a source control repository. So one of the things that you might do is you might utilize something like Subversion or SourceSafe or one of those applications for tracking or doing version control. There's a number of different ways that we integrate with those through the fact that we run within the context of Eclipse. Finally, I'd like to show you the when we right-click on our project or we right-click on the source folder. One of the things I'd like to show you is that when we come down here to force.com, there's a number of different things which are available. The refresh from server and the save from server. What these do is refresh from server says go out and get the latest copy of whatever might exist out on my org and then download it and overwrite the local copies in my Eclipse environment. A reason you might do this is that somebody might go out through the setup menu, make changes to a class. You want to go out and get the latest copy of that or everything, do refresh from server and bring everything down. There's also save to server, which is the flip side. So save to server is take all my definitions and write them up to the server. An example of using this is, let me show you how another item which is available is the ability to work offline. You can work on your code. For instance, let's say we get on an airplane. We work on our code in the offline mode, so we're disconnected from our org. We can then save our code back up to the servers once we reconnect by using this save to server. Okay? There's also, let me jump back here, back to my source area. So here under force.com, there's also synchronize with server. What this does is this will do, essentially it's a diff that's being performed on the local copies and the copies up on the Salesforce servers. It opens up a compare editor and allows you to compare the different versions of the local copy versus the copy that exists up in your metadata database. The deploy to server, we will talk about that later. Deploy to server is the ability to move our code to our production environment. We'll come back to that. There's also this add, remove metadata components. We can create projects. When we do the lab exercise, we're going to create a project that contains all our metadata definitions. But we can also create multiple projects that contain subsets of our metadata. And one of the things that we can do is either add or remove components from that metadata set that we are now editing in the context of this project. So there's a lot of features. Like I said, developer.force.com has additional information on more details here, but that's kind of the, as quick as a demo I can do for covering the main features within the force.com IDE. All right.
For more information on Salesforce.com training and certification, please visit www.salesforce.com/training.